And well, a nice welcome to this afternoon session today. My name is Tassilo Pellegrini. I'm chair of the session. And in this session, we will address quite an obvious and important topics, the intersection of semantics and interoperability. We have three industry talks today. The first presentation will be given by Max Gärber from PANTOPIX in combination with co-presenter from ZEISS. The co-presenter will participate online. And it's a fun talk about a very interesting project PANTOPIX is doing together with us. I won't dive into the details here. Max, please introduce yourself and yeah.
Thank you.
The stage is yours.
All right, thanks.
Okay.
Yeah. So, welcome everyone. Thanks for joining our talk. I don't think you can see Sonam, so maybe we
Do you want me?
need to stop presenting. Not now, but like in a minute.
Yeah.
So, Sonam and I will present how we combined knowledge graph and LLM agents to support technical question and answering in ZEISS service. It's called the service Copilot, and it's a joint effort by ZEISS Digital Service, Internal Consultancy, and PANTOPIX. PANTOPIX is providing consultancy services and implementation services in the field of technical communication. And I think the following slides will show what that means in more detail. I'm Max Gärber. I'm one of the partners and tech consultant at PANTOPIX, and I'm also part of the service Copilot team, a team of 7 to 8 people currently developing that system at ZEISS. And my co-speaker is Sonam. Yeah, I think best is if she introduces herself.
Thanks, Max. Hello, everyone. Myself, Sonam Chugh, and I'm honored to speak at this conference representing ZEISS. As a part of ZEISS Digital Partners, I focus on integrating knowledge graph with AI to develop intelligent service solutions that support innovation across our different ZEISS business segments. Next slide, please. Thanks. So let me begin with brief overview of ZEISS different segments. So with over 170 years of expertise, ZEISS has grown from microscope manufacturing to global leader in optics and optoelectronics. We operate in 6 key segments. First is like consumer products, which offers binoculars and lenses. Vision care focuses on optical lens and eyewear. Medical technology develops imaging systems and surgical instruments. Microscopy, which is our talk regarding producing microscopes for research and industrial use. IQS provides precision tools. And last but not least, semiconductor manufacturing technology, which focuses on production of microchips. Now I will hand over to Max to give overview regarding the project.
Thanks, Sonam. So we are talking here about ZEISS RMS microscopy solutions, and the challenge in service or field service especially is to provide like the right information, like where it is needed, when and how. So the service technicians, they need to like gather like from vast amounts of information. So they need, of course, ticket system for what is to do. There's like a description of the issue. Best they have also error codes or condition data from the assets directly. There might be best practices collected, or yeah, for sure technical documentation, how to conduct a certain procedure, checklists, all that kind of stuff, customer information, who's my contact person, where to drive, is it in like a certain room, and last but not least, spare parts, because when the field service engineer drives to the location, most of the time that involves exchanging of some sort of part, even if it's just a cable. So it's like vital to know what to tackle. And the information needs to be connected and represented in a personalized way. So the technicians have different skill levels. They are trained on certain microscopes, and only for those they are trained, they are allowed to do the procedures. And also recommendation mechanisms facilitate all of this. So it's not always just search, but given the context that we have, provide already recommendations. So how does the Copilot look like? It's a web application to be accessible on mobile, on the laptop, when they are at the customer side. And it has two main parts. So one part is for information delivery mainly. So all the information assets I have just told about, they are also available through the knowledge graph. So exploring and browsing that information by the knowledge graph, that's the one part. And the other part is interactive Q&A by chat and recommendations that are pre-generated also by use of language models. The recommendations are especially interesting because, like, once you're in the situation that a certain ticket needs to be worked on, we know a lot of information already. We know the product already. We have some problem descriptions. We might also know what component is affected. So based on past similar issues, and that's where LLM comes in, comparing similar cases that have certain solutions, we can already recommend like what the actions could be. So that is one thing. And the other thing is then to dive deeper and ask specific questions about, okay, how specifically could I exchange part X, Y, or what is the part number? And for that, interactive chat is being used. Also, the chat will always have the context that is already known as like the starting point. So when we talk about knowledge graph, what does that mean for us? That's always a knowledge model, which consists of ontologies and taxonomies, and of course the instance data. So it's always like a three-layer structure. For the ontologies, we rely on industry standard ontology. I don't know if IRDS is known. I think it was also mentioned in another talk yesterday. And of course, SCORS as an ontology, but also as a taxonomy. For the ontology, we like specifically say it should be rather an upper ontology, so a having not very specialized classes, like having more broad definition of things and solving the customer specific domain objects or entities in the taxonomy layer. So this is where it gets really company specific. So the different types of components or the different product groups that are available or the different properties that different systems have, they are all modeled in the taxonomy. And the instance data is then linked to or referring to that taxonomy. So for example, you could find instances that say, hey, this asset is a light microscope. It has the following data sheet with those properties. And this kind of microscope has only certain components. Yeah, and we use the ontology as the main integration point for the language model. So the ontology is used, for example, for grounding, for sure, giving the context to the LLM. It is used for entity recognition or extraction. So if a certain question is being asked, you would consult the ontology to detect, for example, what product is the person talking about. And it is used to allow the LLM control the flow of the application. So as you can see here, the linkage between a product and a certain condition that might arise. So a certain microscope is running for several hundred hours, which might raise an alert, hey, some part would need to be replaced because that threshold is arrived, which leads to a service order, which would lead to a specific maintenance procedure that you need to conduct because of that alert. But only if you have the connection between the data, you might infer that, hey, this condition data is coming from a specific component. In this case, it's coming from the cathode or filament, like the element that emits the electrons, which wears out. So you would already know, okay, what is the spare part actually for this specific procedure? And only by having that information linked, you can provide that already to the service technicians. Yeah, control flow is quite an interesting aspect because by introducing agents, and by agent we only mean an LLM that you allow to control the flow of your application. So it's not hard coded. It's not like if this then else, but you give the parameters to the LLM and let it decide. And there we have like 3 stages. The first one would be simple routing system. So the LLM just more or less transfers the task to a certain tool or specialized agent. State machine, which means you have repeated evaluation of the result, and the LLM is allowed to decide if the task is fulfilled or not. Or like the last stage would be a fully autonomous agent, which also has memory and can behave differently in following runs. We are currently more at the state machine level. So we allow the agents to assess the result and decide if it needs to go like into another loop, use more tools, or if the task is done. And how that exactly works, Sonam will tell you now.
Thanks, Max. Thanks. So thanks, Max. Now I will briefly explain like how Agentic RAG works. So Agentic RAG using the plan execute is a framework that combines RAG with the autonomous agent behavior, enabling AI system to not only retrieve and generate information, but also plan tasks and execute action across workflow. So for example, upon receiving a user request, a system generates a task list based on the user intent and agent capabilities. Now, each agent can use multiple tools and make decisions independently. As Max was previously mentioned, a global context is maintained throughout the process to ensure transparency. Now, the tasks are carried out like step by step, and each result updates the shared state. This allows the system to adjust the plan dynamically and as the new information becomes available. Next slide, please. So now we will go through how this is being adapted in our Service Copilot project. So starting with the most critical component, which you can see at the bottom, is the knowledge layer. At the heart of the system lies the shared semantic foundation that all agents rely on. This knowledge layer includes ontologies, which define our domain-specific concepts and their relationships, vocabularies, which include standardized terms that should be used across system, and rules and facts defining how systems should behave. This layer enables agent to understand user intent, resolve ambiguity, and link information across system. For example, connecting a service order to a particular product. Surrounding the knowledge layer is a set of specialized agents, each responsible for a distinct function. At the center of the system is the planner agent. This agent acts as an orchestra. What it does is like it analyzes the user's request, creates a structured plan, and assigns tasks to the appropriate agent. Now the planner agent collaborates with two distinct groups. On the left-hand side, you can see like helper agents, and on the right-hand side, you can see the domain agents. So let's start with the helper agents, which include the interaction agent, which manages the conversation, like how should be the tone of the chat and ensures that there is a smooth communication. We also have inference agent, which fills in gap when the information is missing, like if there is like date missing, so these kind of information is filled by the inference agent. Now moving on to the domain agents, which brings in like the specialized expertise, which you can see on the right hand side. The content agent, which retrieves the relevant information from our service manuals and documentation. Then we have another agent, which is the troubleshooting agent, which investigates like what was the root cause for a particular problem. And the last would be the service agent, which provides the device specific insight for our product. All these agents have access to the knowledge layer and they share a shared memory so that they all have the same state. This architecture enables dynamic planning, intelligent collaboration, and have effective handling of the complex service request. Next slide, please. So now let's walk through a practical example from the Service Copilot project to illustrate this. Consider the user request. I need a case study with the technical details for the product related to a particular service order. So as you can see, this is like a multi-layered request. So what it involves is it's identifying the product linked to a specific service order first thing. And the second thing is retrieving the technical documentation for that product. So how does the planner agent sees this request? So the process begins with the planner agent, which analyzes the request and breaks it down into two tasks. First, for the service agent to identify the product linked to the service order using the structured taxonomy, which is our knowledge layer. And the next, for the content agent to retrieve the technical information from service manuals related to the product. Next slide, please. So this screenshot shows the agentic workflow for the same query we just discussed. So now my question was like, I need a case study with the technical details for the product related to a service order. So on the left-hand side, you can see the messages exchanged between agents as the system processes the request step by step. It all starts with the intent agent, which identifies the user's goal. Then the planner agent steps in and creates a task list to fulfill that user request. The first task is to identify the product linked to the particular service order. To do this, planner agent calls the service agent, which uses the product taxonomy and device data to find the product. Once the product is identified, the planner agent adds a second task to the list, this time for the content agent. The content agent uses retrieval augmented generation, also known as RAG, to extract technical details from the service manual. Throughout this process, all agents operate on the shared layer. This layer helps them to understand the context and collaborate effectively. This example really shows how system handles complex service requests with smart coordination and flexibility.
Last one.
Yeah, next slide, please. So to give you like brief how this helps our business is like, so the knowledge infused agentic RAG offers a strong business value through its modular design, making it easier to maintain and scale. As you have always all seen that we have maintained the agents as separate chat component, so it allows to handle the complex questions more accurately. The key strength which we have observed is the knowledge layer, which helps the system understand the context better. The system can also manage the different ways of asking questions, like someone asks using the abbreviation or synonyms, and our system can give the precise answer. And we also saw that it can also handle like multi-step queries so that it calls like two agents, which is also possible. So overall, this leads to better performance, more flexibility, and the smoother experience for the user. Thank you, and I will hand it over to Max.
Yeah, thanks everybody. I think hope that was insightful information about Service Copilot.
Thanks very much to the presenters. We have room for
Can you stop
1
the
to
share?
3 questions. Yes, please.
Yeah, I'm curious about the relationship between those assets you're on the right side of that one slide, like the relationship between.
Which slide?
The one with that had the content and that one.
This is
The content and the troubleshooting. I'm just curious, like the relationship between like the knowledge graph and I assume you have some kind of structured content like documentation or something that you're, or is it all unstructured documents?
it's both. It's unstructured and structured. So
Like data or something? Or?
not quite, but it's IRDS. So
Oh,
it's
okay.
structured technical documentation with metadata.
Yeah, and I'm just curious about the technical connection between those. Like, are the content objects like objects in a knowledge graph? You know, like in a triple?
Not
or?
not fully. So so each procedure has a representation in the knowledge graph with its metadata, but not with its content. So only like the
So it's the
title.
metadata
Yeah.
associated with the content.
Yeah,
aspect.
exactly.
Gotcha.
So we know how to get everything.
This system is now being used, or is
This in production.
it's in
Yeah. So there are around. Sonam, how many? 1,200?
Yeah, there are like around 1,000 users who have been actively using this application.
We just moved from the before it was like plain rec style, but that did not allow us to solve like complex questions that would really, what Sonam just explained, need to follow several sources and retrieve from different and then combine into the answer. That was not possible or not as good. And with the agents that are specialized on each task, that works much better. And also the I think the planner is working quite good. So we are using feedback system, like with up and down voting, to validate the usefulness. And
that's a great endeavor because this is rather new technology.
Mhm.
I mean, new and or using it already maybe for 1 year, something like that. Because
yeah, if even.
development-
So the rack system was in production already for over a year, like 1.5, and then like let's say, what was it, Sonam, 8 months ago?
Okay,
Yeah.
that was a good, I think quite short development period.
Yeah, we are quite busy.
Yeah. Well done.
Does it support multiple languages or is it English only?
So it supports multiple languages, but straight by the language model. So there's also translation functionality built in, but it really uses the language models to do the translation. Mainly we focus on English. Yeah.
The planner, does it take into consideration location and time zones? Or
It
is
surely
just
does, yeah,
parts?
but I'm not aware how exactly that happens. Would you know, Sonam?
It's not, can you repeat the question, please?
I was wondering if the planner has to do only with the product components, or is it really to work as a scheduler? So you
No,
basically can
not as a
complete
scheduler,
time
no.
zones.
I'm curious about the user interface. You said it's just a web app at this point,
Mhm.
or is it, like, is there anything like a iPad version for the field engineers or something like that, or is it?
I mean, they can use it on any device,
It's
so
just like a
that's
progressive
yeah.
Yeah, I'm afraid we need to move on
Okay.
to the next presenter. Thanks
Thanks
very
again.
much again.
Thank you.
But you raised a lot of interest. It's a very nice use case. Knowledge graphs and